Hey guys, so this is part two of our two-part series on understanding series and data frame. In our previous discussion, we talked about what is a list and what is a dictionary and how to construct them. So in this video, we'll be focusing on how to use lists and dictionaries to construct series and data frames. I wanted to go into a lot of detail here because when you look for resources online and also in textbooks, you would see that the way authors would reference series and data frames are using lists and dictionaries. So it's quite important for you to be familiar with this notation. All right, so now that we understand what are lists and dictionaries and how to denote them, we can proceed to discuss what is a series. So a series is a one-dimensional array of index data. So essentially, to discuss series, we just use our most basic list. So our first example here is a list that is composed of three elements A, B, and C. And to create a series out of this list, what we need to do, well, first we need to import pandas as PD. So we are importing the pandas library and we are assigning PD as the variable to represent pandas. So what we wanted to do here is to create a series out of this list. So to do that, we write pd.series with a capital S and surround our list with a parenthesis to denote that this is a function. So pressing Shift Enter to run this code will output our series. And the first thing that we notice here is we have this extra column here composed of 0, 1, and 2. And based on our previous discussion about the index, this is essentially the index position of each of the element in our series. So as we mentioned earlier, the first element would always have an index position 0. The second element would always have an index position 1. And the third element would always have an index position 2. So these are default values of indices, and that is the reason why we are seeing 0, 1, and 2 here. And also you could see that our series is denoted as a column, which means that these values are vertically arranged. And also you could see that it is a plain white background. So I just wanted to note that, and later on I would want you to see the difference between a series and a data frame visually. So aside from seeing how a series would look like, we could also determine if an object is a series. So by the way, this whole code here is considered an object in Python. And so we could also pass this object into the type function. And we could run this by pressing Shift Enter. And we could see that this outputs the type of the object. And we could see here, this is a series. And finally, I would like to show you that we can also assign this list into a variable. So it will be easier for us in terms of syntax to refer to this list. So let me use the variable list1, and I could assign it to the list that we have just created. And we could just follow the same code that we have used. And instead of explicitly referencing the list as is, we could use the variable. And if I run this using Shift Enter again, we get the same result. And so that is our list 1. And to continue our discussion, let me just create list 2, which is the set of our second column composed of the elements E, F, and G. And I'm just coming from our Excel example here. Our list 1 is, you could think of it as the column. So it is composed of these three values, A, B, and C. And our list 2 is our second column, which is composed of the values E, F, and G. And I would just like to highlight that each of the first elements in our list is having an index position 0. So A and E would have an index position 0. We could think of it as a row-wise position. And then each of the second elements in our list would have an index position 1, which is the elements B and F. And finally, our third elements in our list would have an index position 2, which is composed of the items C and G. So given that, let us now proceed with our discussion of data frames. So data frames are two-dimensional arrays of indexed data. So we could think of a data frame as a collection of series. So going back to our table here in Excel, we mentioned that our first series, which we denoted by list 1, is composed of A, B, and C. And our second series, which we have denoted by list 2, is composed of the elements E, F, and G. So essentially, if we combine them together, this is what we call a data frame. So the difference is that the data frame is composed of two dimensions. So we could think of it as the first dimension being the row, and then the second dimension is the column. So the important thing to note about a data frame is that it is a combination of series, but at the same time, the first elements of each series would share the same index. Also, the second elements would share the same index value, and also the third. So what we are saying is that when we combine a series into a data frame, the first elements in each of the series that we have combined would have an index position 0. The second elements in the series that we have combined would have an index position 1, and the third elements in each of the series that we have combined would have an index position 2. So to create a data frame, we would be using pd.dataframe, and make sure you are using capital D and capital F. And first, let us use our list 1, just to show you that it is also possible to create a data frame with just one list. So in essence, what we are doing here is we are passing this list here, which is composed of the elements A, B, and C, into the data frame function. So we are converting the list into a data frame. So as I mentioned earlier, in terms of the visual representation of a series is more, I guess you could say, plain, while a data frame is visually represented with alternating gray and white shaded lines, and also you have this line, and also you have this additional column value here, which is, for now, it's 0. We still have these index positions 0, 1, and 2, similar to the one in the series, but note the difference of this additional 0 column label. And this is essentially what we're saying is the column name. So we could think of it as the first column having the index position 0. So our list as a set is assigned the index position 0 column-wise, while each of its elements is assigned each of the index position. So in this case, it is a reminder that a data frame is a two-dimensional array. Now, we mentioned earlier that a data frame is a collection of series. So how do we combine our list 1 and list 2 so that we would have a data frame that has the values A, B, and C on the first column and E, F, G on the second column? So the first instinct, I guess, if we are not familiar with Pandas notation, is to put a comma after list 1 and then put in our list 2. So actually this is not correct, but I just wanted to show you how it would look like if we run this. So first of all, we got an error because I haven't executed this line of code yet. So let me execute that so that we have assigned the list E, F, and G to the list 2 variable. All right, now let's try this again. So now you can see that the result is not a data frame where our first column is our first list and our second column is our second list. So what happened here is that the first parameter in the data frame function, if I press Shift Tab here, you could see what are the parameters that this function takes. Let me just expand this. So our first parameter is the data, and that is list1. And because we have put comma and then we haven't explicitly mentioned what is our second parameter, we just put in list2. So we have assigned list2 to the second parameter, which is the index. So that is exactly what happened here. List1 is our data, and list2 has been assigned as the index. So you could see here that the index can also be changed. We don't necessarily have to be stuck with the default values 0, 1, and 2. But this is not what we want to do. And now our question is, how can we create a data frame from our list? So what we need to do is to pass one element into our parameter. And so what we need to do is combine these two lists into one element. And how do we do that? We come back to our concept of lists. So initially we said that a list can also be composed of multiple elements or multiple lists. So this is exactly what we want to do. So what we need to do here is simply surround our two variables in square brackets, and in that way we are passing one element into the first parameter of the data frame. So let us see how that would. Let me just remove this so we can see what is the difference between the results. So if I run this, now you could see that we have indeed combined our lists. However, you could see that the first list, our list 1, the elements are spread row-wise as opposed to column-wise, A, B, and C. And the elements of our second list is also spread row-wise. So what does it mean? So we're saying that when we pass a list into the DataFrame function, the first element or the first sublist in our list would be considered the first row, while the second list in our sublist will be considered as the second row. But what if we want to have a data frame that is composed of A, B, and C on the first column and E, F, and G on the second column? Since this is an introductory explanation, I would not be discussing how to use pivot or other functions. I would just want to show you how to write this in list notation. So to do that, let's write it manually. We will still be using a list of lists. So again, what we have mentioned earlier is the first element in our sublist will be considered as the first row. So to do that, we need to write the value A. And since it's the first row, the second element in our sublist is E. So let's see now how that would look like. So as we could see now that our first row is composed of A and E, and they are in the first list. So they are in row 0, which is the first row. And the first element in our list, in our sublist, is denoted by the index position 0 column wise, which is A. And then the second element in our sublist is denoted by index position 1, letter E. So we just continue to write our second list, which is composed of the elements B and F. And let's see, I've just run it again using Shift Enter. And finally, we create our last list, which is composed of the value C and G. So this is how we would write our list if we wanted to create this version of our data frame. So maybe just to clarify the difference, right? Let us use our list 1 in terms of how it actually looks like, right? So list 1 is a list of A, B, and C, and list 2 is a list of E, F, and G. Let me run this Shift Enter. Okay, so you could see that our version here has 3 sublists, therefore it has 3 elements, and therefore it has 3 rows. Each of the sublist has 2 elements, is composed of 2 values, and so therefore we have 2 columns. Compare that to our version here, which is composed of list 1 and list 2. So meaning we have 2 elements, which is the first sublist. So therefore we have 2 rows. The first sublist being the first row, and then the second sublist being the second row. And each of our sublists is composed of 3 elements. So we have 3 columns representing each of the elements in our sublists. So notice what we mentioned earlier, a data frame is composed of series that share the same index. So in this example, we say that the first series A, B, and C share the same row index 0, 1, and 2 as our second series E, F, and G. So the way that our data frame would work is that the elements, the values in our data frame, they all would share the same index, row-wise and also column-wise. If they did not share the same index, you would see them in a separate row. But for now, let us just simplify our discussion and say that a data frame is composed of series where the series share the same index positions. So far, we have been constructing data frames using a list. So let me just create a header here to differentiate this section where we have used a list to create a data frame. And let me create a new section here where we would create a data frame using dictionaries. So to create a data frame out of a dictionary, let us go back to our discussion of dictionaries here. And let me copy the first dictionary, the simple dictionary that we have created. So we will be using the same function, data frame, and we will be inputting our dictionary as the first argument to our function. And one modification we have to do here is to convert our values into lists. So let me just surround A and E in square brackets. So if I run this using the Shift-Enter key in our keyboard, you would see that our data frame is composed of 2 columns and 1 row. So essentially what we're saying here is that each key and value pair that we pass to the data frame as an attribute will represent 1 column in the resulting data frame. So the first key value pair with a key of 0 is assigned to the column 0. And the key with value 1, the second key value pair, is assigned to the column 1. So if I extend or include the other elements in the first list, which falls under the key 0 with the value of our list, the first list, then if I run this, I will get an error because what it would say here is that arrays must all be the same length. So what I need to do is to include the same number of elements into our dictionary. So each of our values in our key value pair would have 3 elements each. And again, our first key value pair is assigned to the first column, and our second key value pair is assigned to the second column. So what we could see here is exactly how we define the data frame, which is a combination of 2 series. The first series being the values, the list of values that is assigned to the key 0. So our first series is A, B, and C. So when we talk about a series, it is again the values in 1 column. And similarly, For our second key value pair, our list of elements in the values for the key number 1 is our second series, which is the values in our second column, E, F, G. So that is the reason why we say that a data frame is a combination of series that share the same. So for each of the first element in each of the series, they share the same index value 0. And then for each of the second element in each of the series, they share the index value 1, and so on. And the third element shares the index value 2. So at this point, what I just wanted to tell you is that these index values are the default index values, and we are allowed to change these values by using functions or by assigning values to them. For example, these 0 and 1 in the columns, we call them column index. We can assign values to them so that our columns would have a column name. We will be discussing this in our later videos. Also, similarly for the row indices, we can also assign different values to these. And so we can refer to each row not only by their default index values, but also with any values or any label that we want to refer it to. We will be discussing more of this when we discuss the index, which will be our next video. But for now, I just wanted to tell you that these index values are default values and can be changed. So similar to our first example here, where we created a data frame using a list with one column or one series, I just wanted to show you that this is also possible with a dictionary, simply by removing the second key and value pair. So I just run this using a Shift Enter key again. So when we create a data frame using a dictionary, each key value pair represents one column in the data frame. So the final example that I wanted to show you for this topic is how to use multiple dictionaries as an input when we create a data frame. So for that, I would go to our example here, where we have a list that is composed of multiple dictionaries. So again, our list is this one list, which is represented by the square bracket. And we have 3 elements in the list. And each element is a dictionary, and each dictionary is composed of 2 pairs of key value pairs. And notice that our key value pairs would always be 0 and 1. And we only change the elements on each of the values. So let us copy this. And let us use that as an input to our pd.dataframe function. So we have just a bit of syntax error here. Let me just clean this up. And let's see if this would run. Okay, here. So now we see that it is also possible to create a data frame using a list comprised of multiple dictionaries as elements. What is important to note here is when we create a data frame, we need to have the elements in our data frame to share the same index labels. So column-wise, we need to have 0 for each of the first keys in our dictionary. So because all of the elements in the first column need to have the same column index label. So that is why we are using 0 for each of the first key value pairs in each of our dictionary. Similarly, for each of the second elements in our dictionaries, it needs to have the same index key, which is 1, so that each of the elements in our second column would share the same value 1. So this choice of 0 and 1 for our index keys, as I mentioned earlier, these are default values. However, we can change it. So just to show you that we can assign different values as index keys in our dictionary so that we will change this label. Let me just change each of the ones to twos. Oops, okay, and let me run. So now you see that it is indeed allowed that we change the value of our column label or our column index. What is important is that the index keys are the same for each of the element in our data frame. So let's see what happens if one of our keys in our dictionaries don't match. Let's change this to 1 and let's keep the rest to 2. Alright, so let's run this by pressing Shift Enter. What we will get is an additional column where the dictionary with the value 1 will be kept in one column and the dictionary with the value 2 will be kept in another column. So that's the reason why we say that we need to have the same keys in our dictionary. So what we could see here is that we have a series A, B, and C that all falls under the same column header 0. And then we have a second column, a second series, where the value of the column label is 1, and there's only one element in the series. So there's only one non-null value in the series. So when we see this NaN, this is the representation of a null value. So when we refer to this column, when we refer to column 1, we would still have 3 elements. However, only the first element is a non-null element. Similarly, for our second column, we have 3 elements here represented by the first row being a null value, and the second and the third rows being represented by F and G based on these key values number 2. So finally, let me just put this back into its original form. And that is it for this video. If you found this video helpful, please don't forget to hit the like and subscribe button and watch out for my next videos where we would be continuing our discussion on how to use the Pandas library for data analysis and data manipulation. See you then.